Welcome all of you. Welcome to today's class of Pharmaceutical Organic Chemistry, which is by AKTU, APJ Abdul Kalam Technical University. I am Rosalind Mishra, Assistant Professor, ITS College of Pharmacy. In today's class, we shall be dealing with various qualitative tests for esters and chemical reactions of carboxylic acids. Now, I am dealing with this unit of carboxylic acids and amines, okay, wherein lot of topics in relation to carboxylic acids has been discussed and shall be discussed in the further classes. Okay. We will just have a brief glance into the unit per se of aliphatic carboxylic acids and aliphatic amines. Okay. So, in this unit, under this unit, we shall be dealing with the following topics: acidity of carboxylic acids, effect of substituents on the acidity of carboxylic acids, inductive effect and qualitative tests for carboxylic acids. We shall be dealing with amides and esters, structure and uses of acetic acid, structures and uses of lactic acid, tartaric acids, citric acid, succinic acid, oxalic acids, salicylic acids, benzoic acids, benzyl benzoates, dimethyl phthalates, methyl salicylates and acetyl salicylic acids. So, these are all the derivatives of carboxylic acid about which we shall be learning in detail. Apart from this, we will also have a glance on aliphatic amines. Okay. So, the basicity of aliphatic amines will be discussed in details. Effect of substituents on basicity shall be explained in detail. Qualitative tests, various qualitative tests in relation to aliphatic amines, we will be discussing them. Apart from which, qualitative structures and uses of derivatives of amines such as ethanolamine, ethylene diamine and amphetamine will be discussed in the preceding classes. Okay. So, now let us look into the qualitative test for esters. Okay. Now, procedure. The procedure involving this qualitative test is: esters, unlike anhydrides and acid halides, they do not react with water to give acidic solutions. Okay. They do not react with acidic hydroxylamine hydrochlorides. They do, however, react with alkaline hydroxylamines. Okay. So, one of this test is alkaline ion hydroxamate test. As I told you, esters, unlike the anhydrides and acid halides, they do not react with water. Okay. Generally, anhydrides and acid halides reacts with water to form an acidic solution, but this is not the case with esters. They also do not react with acidic hydroxylamine hydrochlorides, but yes, they do produce reaction in the presence of alkaline hydroxylamine. Okay. So, one of these tests is alkaline iron hydroxamate tests. First, the unknown is tested with iron chloride alone, okay, to a solution of 1 drop, mostly 30 milligrams of unknown in 0.5 ml of 0.5 normal hydroxylamine hydrochloride in ethanol is taken. Okay. So, 1 drop consisting approximately 30 mg of the unknown is dissolved in 0.5 ml of 0.5 normal hydroxylamine hydrochloride dissolved in ethanol. To this, 2 drops of 20% sodium hydroxide solution is added. Okay. So, to the above mixture, 20% sodium hydroxide solution is added dropwise. This solution is then heated to boiling. Then it is cooled slightly and we add 1 ml of 1 normal hydrochloric acid. Okay. If cloudiness develops, then further another ml of ethanol we add into it, okay. Followed by 10% iron chloride solution is added drop wise with thorough mixing. A red blue color indicates a positive test, okay. So, if the unknown solution produces a reddish blue coloration, then that we can say that the test is positive, okay. Then we compare our unknown with the known ester. Next, in order to clean up this, we first neutralize the solution with sodium carbonate, then dilute it with water and it can be flushed down the drain. So, for the testing of esters, the first test is alkaline iron hydroxamate test, where the unknown solution, 1 drop of the unknown is mixed with 0.5 ml of hydroxylamine hydrochloride, which is dissolved in 20% sodium hydroxide solution. Next, this solution is heated and boiled and 1 ml of hydrochloric acid is added. If cloudiness gets formed, then 1 ml of ethanol can be added to it. The next step is addition of 10% iron chloride solution drop wise with thorough mixing. Okay, so, the color change observed here is red blue color formation. This reddish blue color formation indicates a positive test. This indicates a positive test. This we can compare with a known ester. Next, now moving on to the chemical reactions of carboxylic acids. In our previous classes, we had discussed in detail about the properties of carboxylic acid and the preparations of carboxylic acid. In today's class, we shall be learning in detail about reactions of carboxylic acids. Okay. These are pretty important. We shall be dealing with a number of reactions and we shall be looking into the functional groups or the group which is responsible for reactivity of a carboxylic acids. Okay. So, reactions of carboxylic acids can be divided into 4 categories. Okay. So, carboxylic acid reaction can be divided or placed into 4 different categories. Number 1, reaction at the acidic hydrogen on the carboxyl group. Okay. So, here if we see, this is the functional formula, this is the formula for carboxylic acid. Okay. So, the first reaction happens at the acidic hydrogen of the carboxyl group. Reaction can also happen at the carbonyl carbon. Okay. So, the first reaction category is reaction at the acidic hydrogen. The second category is reaction at the carbonyl carbon. Next is reaction at the carboxylate oxygen. Reaction at the carboxylate oxygen. Okay. Finally, reaction that lead to loss of carboxyl group as CO2. Okay. So, these are the 4 categories of probable reactions which can happen with carboxylic acids. Number 1, the acidic hydrogen could react. Number 2, the carbonyl oxygen could be the reason for reaction. Number 3, the carboxyl oxygen could be the reason for reaction. Number 4, removal of the carboxyl group C double bond O minus group in order to get evaluated as carbon dioxide. So, these are the various probable reactions for a carboxylic acid. Okay. So, the reactions of carboxylic acids can be directed to various sites on the carboxyl group. As we have discussed earlier, reaction sites on the carboxyl group of carboxyl acids. Electron rich oxygen targeted by electrophiles. Okay. So, this electron rich oxygen or the carbonyl oxygen is targeted by electrophiles such as protons. Acidic proton is targeted by bases. This is very important. via this description we will be able to know that which group is attacked by which chemical constituents. Okay. So, the first oxygen or the carbonyl oxygen can be attacked by electrophiles, whereas this hydrogen atom can be attacked by bases or can be targeted by bases. Electron deficient carbon can be targeted by nucleophiles. The electron deficient carbon can be targeted by nucleophiles. Okay. So, now let us look into the first reaction. Reactions of carboxylic acids with strong bases. Carboxylic acid RCOOH reacts with a strong base or sodium hydroxide to form a sodium salt of carboxylate ion or RCOO minus. Okay. Hydrogen atom is removed from the carboxylic acid. Here if you see, the acidic proton is targeted here by base. Okay. So, this reaction is depicted in our first reaction, wherein the acidic hydrogen atom is targeted by a base. Okay. This hydrogen is removed to form RCOO minus, RC double bond O minus, which is further targeted by Na plus, okay, forming carboxylate anion RCOO minus Na plus and evolution of water molecule, release of water molecules. Bases such as metal hydroxides like sodium hydroxide and potassium hydroxide and amines abstract the acidic proton on the carboxylic acids to form a carboxylate anion. Okay. So, if we move on towards writing the common reaction or generalized reaction, RCOOH plus OH minus leads to formation of carboxylate ion RCOO minus, carboxylate ion along with removal of water molecule. For example, benzoic acid upon treatment with sodium hydroxide, benzoic acid upon treatment with sodium hydroxide leads to production of sodium benzoate, wherein the acidic hydrogen is attached by the base and removal of acidic hydrogen atom leads to the formation of a benzoate salt or sodium benzoate with the removal of water molecule, with the removal of water molecule. So, this is how an acidic hydrogen atom is attacked by a base. Next. The next reaction is reaction of carboxylic acid with diazomethane. Okay. So, diazomethane can be written by the molecular formula CH2N2. Diazomethane can be given by the molecular formula CH2N2. Carboxylic acid upon reaction with diazomethane forms a benzoate again. It forms a benzoate. As you can see here, methyl or phenyl benzoate. RC double bond O, OH upon reaction with diazomethane, this acidic hydrogen atom is again attacked to form RC double bond O, OCH3 with the removal of an azide. Okay. So, पहले reaction में भी हमने देखा, even in the previous reaction we have seen that sodium hydroxide attacks the acidic hydrogen atom or a base attacks the acidic hydrogen atom. Similarly, even in this reaction we can see a strong base, for example a diazomethane attacking the acidic hydrogen atom to form the resultant product. Okay. So, here if we look into the common reaction, benzoic acid upon reaction with diazomethane forms methyl benzoate or phenyl benzoate and an azide. Okay. So, this is how our first reaction came true, or our first prediction came true, wherein acidic proton is targeted by bases. Okay. Acidic proton is targeted by bases. This hypothesis or this first principle is substantiated with the help of two examples, where carboxylic acid reacts with sodium hydroxide to form the respective salt. Similarly, carboxylic acid reacts with a strong base like diazomethane to form the corresponding product with the removal of acidic hydrogen atom. Okay. Now, the mechanism involved here is, first, deprotonation of the acidic proton on the carboxylic acid happens. Okay. So, what is happening here is, first this carboxylic acid loses the acidic proton, or deprotonation happens, forming RCOO minus or a carboxylate ion and a methyl diazonium ion. Methyl diazonium ion. Okay. Next step is loss of nitrogen. So, RCOO minus leads to loss of the nitrogen atom here, okay, forming a methyl ester, So, what is happening in this reaction? When carboxylic acid reacts with a diazomethane, or reaction of carboxylic acid with a diazomethane leads to esterification of the carboxylic acid, forming RCOOR, leads to esterification, forming RC double bond OR. Esterification of the acid with the help of a base, for example diazomethane. Next reaction, acid catalyzed esterification of carboxylic acids. Okay. The acid catalysts can be provided by strong mineral acids such as sulfuric acids. Okay. So, acid catalyzed esterification of carboxylic acid can happen with the presence of a strong acid such as sulfuric acid, hydrochloric acid, phosphoric acid, or other organic acids such as benzene sulfonic acid or paratoluene sulfonic acids. Okay. So, what is happening here is, carboxylic acid reacts in the presence of these acids, for example sulfuric acid, hydrochloric acid, phosphoric acid, other organic acids such as benzene sulfonic acid, paratoluene sulfonic acids, etc., to form an ester. Okay, to form an ester, RC double bond O R dash. Okay. The previous one was base catalyzed, wherein diazomethane led to esterification of the acid. Here in the next reaction, this reaction is catalyzed by acids, okay, wherein carboxylic acid is esterified into an ester compound. The traditional method for converting carboxylic acid to ester is through an acid catalyzed esterification. Okay. So, this is considered to be the traditional method. In the presence of an alcohol, commonly referred to as Fischer esterification, a very important reaction, Fischer esterification, wherein a carboxylic acid is converted into an ester in the presence of an acid and alcohol. Okay. Catalysts, the reaction is catalyzed by an acid, whereas the substituent is an alcohol. Okay. So, this esterification reaction is known as Fischer esterification. What is happening here? Butanoic acid reacts with methanol or an alcohol to produce, or in the presence of an acid, for example sulfuric acid, which is acting as a catalyst. The sulfuric acid here acts as a catalyst, okay, to form methyl butanoate, which is an ester. Okay. this CH3 group is obtained from the methanol and this is the parent acid. Okay. So, esterification of parent butanoic acid happens in the presence of an alcohol and a strong acid such as sulfuric acid. Again, this happens in the presence of water. This happens in the presence of water. Next, reaction of carboxylic acids with amines. Moving on to the next reaction. Amines, being organic bases, react with carboxylic acid to form ammonium salts. Okay. So, amines react with an acid to form a base or to form an ammonium salt. Amine being a base, a very common reaction. We know very well acid reacts with the base to form a salt. Okay. So, this is the reaction which is happening here. Amine, a base, reacts with carboxylic acid which is acidic in nature. Obviously, the resultant product will be a salt. Okay. So, RCOOH or an acid reacts with an amine to form RCOO minus and salt, ammonium salt. Okay. Now, let us take for example, if you look into the mechanism, then RCOOH plus the amine forms ammonium salt with the removal of the acidic hydrogen atom via the removal of acidic hydrogen atom. Next, for example, when benzoic acid reacts with an amine, then the product form is sodium benzoate and the respective salt of amine. Okay. Next, moving on to the next reaction, wherein carboxylic acid is seen reacting with phosphorus pentachloride. Now, carboxylic acid reacts with phosphorus pentachloride to provide acid chlorides. Okay. Acids, for example, RCOOH or carboxylic acid reacts with phosphorus pentachloride, a halogenating agent PCl5 or a chlorinating agent phosphorus pentachloride to form a resulting RC double bond O acid chloride Cl. Okay, RC double bond O Cl with the removal of phosphorus oxychloride and hydrochloric acid. Okay. The success of this reaction depends on the strength of phosphorus bond or P double bond O bonds, depends upon the strength of P double O bond that is formed in phosphorus oxy trichloride. Stronger the bond, more successful would be the reaction. Now, for example, 3,5-dinitrobenzoic acid is our substrate or starting material. This is the form of carboxylic acid we are taking, 3,5-dinitrobenzoic acid. Upon reaction with phosphorus pentachloride or a chlorinating or halogenating agent, reacts with phosphorus pentachloride to form 3,5-dinitro. As I said, OH group is removed and acid chloride is formed. So, 3,5-dinitro benzoyl chloride group is formed. 3,5-dinitro-benzoyl chloride is formed with the removal of phosphorus oxy trichloride plus hydrochloric acid. Okay. Stronger the P double bond O bond here, better is the reaction. Okay. So, chemical properties or chemical reactions, another form of it is reduction of carboxylic acid to form primary alcohols. Carboxylic acids are reduced to primary alcohols when treated with a strong reducing agent such as lithium aluminium hydride. So, carboxylic acid undergo reduction in the presence of lithium aluminium hydride to form an alcohol. to form the corresponding alcohol. Okay. Similarly, benzoic acid, when reacted in the presence of lithium aluminum hydride, it forms a corresponding alcohol. Medium strength reducing agents such as sodium borohydride that reduce aldehydes and ketones are not sufficiently strong to reduce carboxylic acids. Hence, strong reducing agents are required for this. So, with this we complete our reactions of carboxylic acid. Following are the references. I hope all our classes are of utmost importance to all of you. So, with this we have tried completing discussing about various properties, structures, various melting points, boiling points, physical properties, preparations, chemical properties, identification, etc. of carboxylic acid. From next class onwards, we shall be dealing with derivatives of carboxylic acids, their structures and uses. So, see you soon. Thank you.